Hi, I am Jessica Ferweni, a third year computer engineering student, and today our question is on stability. The question reads, check the stability of the system having the following characteristic equation. So here's the characteristic equation. So before you be able to solve this question, you would have to understand what stability is. So in classical control systems, stability of the system describes how the system behaves when a disturbance is introduced or when you put in the input. So with this, to find the stability of the system given the characteristic equation, you have to find whether or not the poles of the characteristic equation lies to the left side or the right side, that is of the S-plane. And with this, if it lies on the left side, it means the system is stable. If it lies on the right side, it means the system is unstable. For this kind of question, to really get how to get its stability, you have to use the Routh-Hurwitz Criterion. You would get to understand more when my colleagues break this question down into the various parts and solve it to get to the right conclusion. Thank you.
My name is Zipporah Apiakubi, and today we are working on the Routh-Hurwitz theorem. So we represent the question given to us with this formula, and it can be represented in the Russian table. We divide our table into rows and columns. Our rows would consist of the S term in the first term, the second term, the third term, as shown here. And the columns, we take the A term from the first term for column 1, the third term for column 2, and it goes on and on like that. For our second row here, we take the terms that we skipped in the first rows and represent them there, and it goes on and on. So for our B term, our B is a determinant of this column 1, and column 2 will give us B1. And the determinants from column 1 and column 3 will give us B2. B3 would be the determinants of the terms following. We continue our table in that way till we reach S raised to the power 0 and A raised to the power 0, which would be our last term here.
Hello, my name is Samuel. We are continuing from where she left off. So using the characteristic equation given to us in the question, we are trying to fill in the Russian table. Now with the S4, we fill in using the coefficient of the characteristic equation given to us in the question. So for the S4, we have the coefficient of the first one to be 1. We skip the second term and take the third term. So the coefficient is 3. Then we skip the fourth term, take the fifth term. The coefficient is 5. Now we have to fill for the S3 too. With that one, we input the ones we skipped, which is S2, which is 2 and 4 in the equation. And this is how the table look like. Thank you.
Hello, my name is Papa Kojo Payne Graham, third year computer engineering student, and I'm here to continue from where my classmates left off. So here I'm explaining how the values for the S square row came about. So here, the S2 row has value B1 and B2. To find the value for B1, I'm going to find the determinant for column 1 and then column 2. So 1, 2, and 3, 4. So all that to be divided by 2, and then it will give you B1 to be 1. So find for B2, we have the first column 1, 2, and then the third column 5, 0 divided by 2. So we are finding the determinant, and the value will be 5. So the value for B2 is 5. So that is how we obtain the value for B1 and B2. Thank you very much.
Hello, I'm Michael, and I'll be continuing from where my colleague ended. So we'll be obtaining the S1 row, which is C1 and C2, and obtaining for C1, it will be the determinant of 2, 1, and 4, 5 divided by 1, and we got -6 for C1. And also for C2, it's going to be the determinant of 2, 1, and 0, 0 all divided by 1, and we had 0 for C2. Therefore the S1 row values are -6 and 0. Thank you.
Samuela and Panaman, and I'll continue from where my book left off. So now we are obtaining the S0. In the S0, we just have D2. To find for D2, we have to take the determinant of the first column and the second column divided by 1. So getting divided by 6, sorry. So computing the values will result in D2 being equal to 5. Effective. The S naught term will always be constant and from the original equation if no rules are skipped. It just means in finding for D2 if no rules are skipped, our D2 tends to be equal to the constant in our general equation, which is S1 plus 2S2 plus 3S squared plus 4S plus 5, which is equal to 0, making our D2 equal to 5, thereby resulting this table. Thank you very much.
Hello everyone, my name is Kofi Bachi and I'll be presenting on the stability analysis. So we've obtained our values for the column 1, getting S to the power 0 to be equal to 5, S to the power 1 to be equal to -6, S to the power 2 to be equal to 1, S to the power 3 to be equal to 2, and S to the power 4 to be equal to 1. So from this, we can conclude that since all of them have positive values, but then S to the power 1 only gave us -6, the system is unstable because it has positive values. It has both positive and negative values. Yes. Thank you so much for your time.
Hello guys, I'm Joshua. So in conclusion from the Routh table constructed from the given equation, the first column contains two sign changes from +1 to -6 and from -6 to +5. Now, because there's a sign change, this makes the system unstable. And then also, according to the Routh-Hurwitz stability criterion, the number of sign changes in the first column corresponds to the number of roots that lie in the right half of the complex plane. So when we try to plot our graph in Python, we realize that two poles lie on the right half plane. Now, because the two poles lie on the right half plane, this makes the system unstable, right? And also, the number of sign changes in the first column corresponds to the number of roots that lie in the right half of the complex plane. So because we have two sign changes, we're going to have two poles in the right half plane. So if we had 3 sign changes, we're going to have 3 roots on the right half plane. So guys, this was our video explaining how we can take a characteristic equation and determine if the system is stable or unstable. Thanks for watching, and I hope that this video helped you.